Today we are going to walk through the technical and scientific dynamics of pneumatic coal injection or PCI. Our focus will be on mechanics of the moving coal from the mill to the furnace and most importantly the physics of saltation velocity, which is the backbone of a stable transport system. The process begins immediately after the coal is dried. We use pneumatic conveying to move the material from the mill to storage vessel located near the blast furnace. To ensure the coal remains stable and dry during this journey, we use dry nitrogen gas as our conveying medium. The coal follows a specific path. It is first lifted via vertical rises to reach overhead storage and is then distributed to the furnace through horizontal pipes, which typically have an internal dia of 50 to 100 mm. The precision is key in these operations. Uh, the uh, the nitrogen gas used for conveying is strictly maintained at a pressure of about zero point 0.5 to 1.5 MPa, which is about 5 to 15 bar gauge. We regulate the amount of coal entering the stream using either a screw conveyor or a rotary airlock to ensure a metered, consistent feed rate. Finally, the coal is held in pressure vessel storage before it is ultimately injected through the tuer. Now, let's discuss the most critical design parameter, saltation velocity. Scientifically, this is defined as the minimum air velocity required to keep coal particles suspended in the gas stream so they do not settle at the bottom of the pipe. This velocity is dynamic. It changes based on the particle size, the density of coal, and the temperature of the conveying gas. In practice, we never run at a bare minimum. We always maintain an excess air velocity of 5 to 10 meter per second above the saltation velocity to provide a necessary safety margin against the blockage. And this extra buffer is help in mitigating all the problems in pneumatic conveying. Comparative analysis by coal type, if we look into the type of coal we use changes our operational requirement. For a standard PCI coal where a 70 to 80% 70 to 80% of the particle are smaller than 75 micron, we require a saltation velocity of approximately 20 to 25 meter per second. Coarser GCI coal actually require a lower velocity between 15 to 20 meter per second. It is also important to note that if the coal contains excessive fines, meaning particle smaller than 10 micron, the saltation velocity actually decreases. While this makes the coal easier to transport, it comes with a trade-off. It significantly increases dust recirculation losses, which is also very important. So, to summarize, for our daily operation, we must always maintain that 5 to 10 meter per second safety buffer above the saltation velocity to prevent sedimentation in the lines. We need to be vigilant about monitoring our particle size distribution as any shift in coarseness will change our transport energy requirement. Lastly, ensuring our nitrogen pressure stays within the zero point 0.5 to 1.5 MPa range is vital for maintaining the integrity of the entire injection cycle.